Okay, the next thing we're going to go over are inverse functions, and we're going to answer the following questions about this graph. So what are the inverse functions pictured here? So we have y equals a to the x, that exponential function, and we have y equals log base a of x, and a is going to be a positive number. How can you tell from the graph that these are inverses? Well, remember that any inverses are going to have the relationship where they are reflections over this line, y equals x, so we can tell that from the graph. You can also tell that the x and y values are switched. He's a really easy one to pick out. So this is 1, 0. Because the x and y values switch for inverses, this is going to be 0, 1, and that's going to happen everywhere on your graph. So if you wanted to prove algebraically that these two functions are inverses, you could start with one of the functions, such as y equals a to the x power, and you could solve this to see what was the inverse. So remember, your first step of inverses is to switch the x and the y. Now, the only way you can undo an exponential function is if you have a log with the same base. So if I did log base a on both sides, log base a and a would cancel out, so I'd be left with y, and then log base a of x would be on my left side. Okay, you could also start with your other function, y equals log base a of x, and you could switch x and y. The only way to undo the log is to use an exponential function, so we're going to exponentiate both sides. A and log base a are going to undo one another because they're inverses, so we'd have y, and then this side would be a to the x. So as you can see, these are going to be inverses. I also want you to remember that the crucial step when finding your inverse is switching the x and y. And then based on our response in question 4, what do you think happens to the domain and range? Well, remember, domain is going to be our set of x values, range is going to be our set of y values. If we're switching the x and y, then we should be able to predict that the domain and range are going to be switched as well for our inverse functions. So I said, for example, the domain of a log function is going to be the range of an exponential function because logs and exponential are inverses. And the same thing's going to happen. The domain of an exponential function is going to be the range of a log function. So remember, for exponential functions, our domain was always all real numbers. So now for a log function, our range is going to be, what? Can you hear it? Yes, it is all real numbers. Okay, so let's keep that in mind when we're doing the next ones. So for part A, I want you to graph f of x equals negative log of base 10 to the x. I am going to let you use your calculator on this, but you could generate a list of values by plugging in easy values here. Like if you did log base 10 of 10, those would cancel out and you'd be left with negative 1. Let's go over how you can do this on your graphing calculator. So if I have the negative log, and if it's base 10, you can just use your common log of x. I'm going to use my standard window. Okay, and I can only see part of my graph there. Okay, so I have negative log base 10 of x, and then I'm going to just look at a smaller value. So from negative 5 to 5 and negative 5 to 5, just like the graph on my paper. Okay, so with my graphing calculator, because of the pixels in the calculator, it looks like it stops here. That's not the case. This is going to keep going and getting closer and closer to this line, x equals 0, and we can verify that in the table. So if we look at our table, okay, our last point here is going to be 1, 0, so that'll be a good one for me to graph, 1, 0. Okay, at 2, I'm at negative 0.3. At 3, I'm at negative 0.47. And so I can put all of those on my graph, and then I can see here, now I'm getting an error. So anything that's going to be lower than negative 1 is going to be an error. The reason why is we can't take the log of a negative function. And we can think about why that happens. So anytime you have a log, if you were to try to take a log of, let's say, we'll do log of negative 10. Well, then that means there should be some value such that 10 to the x equals negative 10. There's no number I can plug in there that's going to give me negative 10. If I plug in negative 1, I don't get negative 10. What do I get? Yep, I'm going to get 1 over 10. Okay, if I had 10 to the negative 2, I'd have 1 over 100, so on and so forth. And that's also why we can't take the log of 0, because nothing to the 0 power will be 0. If you do 10 to the 0 power, what do you get? 1. Yep, all right. So based on those values, you can see it's an error. If you wanted to go to your table set, you could go by different decimals. So if I wanted to go to 0, let's say I wanted to go by, let's go by thousandths here. So now when I go back to my table, again, you can see it's getting closer and closer to this value, but when you have your 0 and you go below, you are going to get an error, okay, with everything getting closer and closer to 3. All right, so what is our domain? So what can I plug in here? Okay, the very first number is going to be 0, and that's going to go up to positive infinity. Remember, your domain is the x's, so even if you're just looking at the graph, you can see the x values are going to stop here at 0, and they're going to continue on to positive infinity. Now remember, this is an inverse from an exponential. For exponential, we had horizontal asymptotes, we had y equals. Now we're going to have vertical asymptotes, we're going to have x equals. And then your range is going to be all real numbers. So this is going to keep going to positive infinity, and this will slowly keep going down to negative infinity. All right, so let's try the next one. We're going to have, we'll plug this in, 1 plus the natural log of negative x. So negative x, all right, I'm going to go to my, actually, let's leave our window as the negative 5 to 5. Okay, so again, it looks like my graph is stopping here, but remember, that's only the pixels. If you have one of the new ones, you can actually see it'll graph like a colored line, which is cool, and it'll show it keeps going. Okay, so a good thing to do would be to pick out a point from your table, and I'm going to change my table, go back to ones. Okay, so I'm getting all of these errors here, but they're positive. Well, why is that? Well, remember, we had the opposite of x, so it's really like I'm plugging in a negative value. So I'm going to have to go towards the negative side of the function. So negative 1, 1 is going to be a good point for me on my graph. And then I can see from my graph that this is going to be approaching the line y equals 0. Okay, and then this is also going to continue. So my domain is going to be my lowest x value to the highest x value. So the lowest x value I can plug in up to negative infinity, and then the highest value would be 0, and then it won't include 0 because at 0 you would get undefined. So that's why I'm going to have a soft bracket. Again, your range is continuing to span all of the y's. So your range is going to be negative infinity to infinity. Your vertical asymptote is going to be x equals 0. That's the line that it's approaching here. Okay, and then for our last one, I want you to try log base 3 of x minus 1. Now, some of your calculators do have a log function where you can change the base. You could go to math, and we'll go down here to log base, and I can do 3, and then I can do x minus 1. Okay, and then life is good, I can graph it. All right, and then I know that this is going to continue, and it looks like now it's approaching a different value. So it looks like it's getting closer to 1. I can also go to my table and I can verify that. Okay, so I could see here, right before I had the error, I have 2, 0, which I put on my graph. Okay, and then it looks like at 3, I'm at 0.63. At 4, I'm at 1. Okay, and so you would be looking at your x values here. So your x values are going to be getting closer and closer to 1 for all of your valid options. Now, if you don't have a calculator that has a log base, then we need to use the change of base formula, which is the log of whatever your log is of divided by the log of your base. We're going to look at that a little bit more tomorrow. But if your calculator doesn't do that, you're going to have to do that today. So this would be log of 3, not tangent yet. Okay, and then we graph, and then you're going to get the same exact graph. Okay, so again, you have to do your change of base, and then the change of base would be the log of x minus 1, whatever your log is of, and that would be divided by log base 3. So your domain for this is going to be 1 to infinity. So 1 is your lowest x value, infinity is your highest. Your range is still all real numbers, but now we're approaching 1, so our vertical asymptote is going to be x equals 1. Okay, in the next section, I'm going to explain more about how to get those vertical asymptotes.